Okay guys, so this is 4.2, reduction of order. The idea in this section is you will be given one solution to a differential, and you're looking to find the second solution, and then eventually we could write it a general solution to this differential. So the way this works is almost like you're using substitution in a way where if you can make y equal to some function u of x times y1, that first function that we got. So what you would have is u of x equal to e to the x this way. Okay. So if you notice our differential here, I want to use that as well to find what would u of x equal. So what we want to do is get to the second derivative. So here it's a, you would have a product rule. So you have u of x e to the x plus u prime of x e to the x. Second derivative is going to be u of x, two product rules, so u of x e to the x plus u prime of x e to the x, and then plus u prime of x e to the x plus u double prime of x e to the x. Okay, so you know, simplify this down just to make it a little bit cleaner. Okay, and now we can substitute in. All right, so meaning I could replace, let's go back up to the differential. I could replace y double prime and y and see what I get here, right? So what I'll have So if I replace those, let me just wait for the 0. So y double prime was u of x e to the x plus 2u prime of x e to the x plus u double prime of x e to the x, and then minus u of x e to the x, and then that's going to give us, cancels, right? And we get 2 u prime of x e to the x plus u double prime of x e to the x, and then that's going to equal 0. So right now we just did some substitution and we got down to this situation that we're in here. Okay, so let's say we factor out an e to the x, right? So I'm still trying to solve for u. Okay, so if I factor out e to the x, I'm going to get 2u prime plus u double prime, and that's going to be 0. Now, I'm just simplifying it. You could keep the of x in there, but you know, it's not a huge deal if you don't have that in there, because all I really want to do is solve this for u. So if you notice, like, e to the x can never be 0. Oh. So e to the x doesn't equal 0, but we know we could then solve this equation here. All right, I'm going to move this over so you guys can see it. So here, if you have 2, let's just write it this way, u double prime plus 2u prime equals 0. It's not really in the form that I like, that we know how to solve yet, but let's just say I make w, another substitution, is equal to u prime, then w prime would be equal to u double prime, and then I could have an equation that looks like w prime plus 2w equals 0. Okay, so you go from basically substituting in twice, trying to get it so it's an easier problem that we have, and you can see that this equation right here is linear. All right, so we have it in that form, and we could get that integrating factor, right? P of x is equal to 2. So your integrating factor is going to be e raised to the integral of 2 dx. So we get 2x, sorry, e to the 2x. Okay, so now I can plug that back in, right? And or multiply everything by e to the 2x. So I have e to the 2x w prime plus 2e to the 2x equal to, oh, I forgot my w, equal to 0. And now we know that this is just the derivative of e to the 2x and w. So if we integrate both, we wind up getting e to the 2x w is going to equal c. Okay, c. All right, so w equals c e to the negative 2x. All right, but again, what did we make w? Well, we made w, let's go back up. All right, so let's go here. So we made w u prime. So we're still trying to solve for u, don't forget that. U prime is equal to w, which is equal to c e to the negative 2x. So in order to go and get what u is equal, we take the integral of this. So I'm going to wind up getting negative 1/2 c e to the negative 2x. All right, and there you could see there is the function for u. All right, and now since we know that is equal to u, right, we could go back. Oh, I forgot my plus c. So let's call that C1 and let's call that C2. All right. And now just so remember where we went from. So this is a long process, but if you go back to where we started, we had this notation: u is y is going to be u of x times e to the x. So if we know u, right, let's use it. E to the negative 2x plus c2 times e to the x, and then you could see we wind up getting a negative 1/2 c1 e raised to the negative x plus c2 e to the x. So you wind up getting that second solution there for what we're looking for. So y2, right, is going to be just e to the negative x. Remember, the reason why it's just that and not the negative 1/2, this is still going to be constant. So your final answer here was y2 equals this. And again, if you want a general solution, we don't really need to have that negative 1/2 there. We could just say c1 e to the negative x plus c2 e to the x. And that would be your general solution. This is what y2 equals. All right. Now there is an easier way. They give you a formula. Okay. So there is a little bit easier way here. And you could see this is if you have it. Now, one thing that you want to make sure it's in the standard form for these homogeneous equations. And then you could use this setup where y2, you're going to do y1 times this integral where you have e raised to the negative p of x dx over y1 squared. So let me show you how to use this formula, and this is really straightforward. Just be careful, that you do certain steps correctly, because it's not really that bad. It's pretty trivial. So if you have a function like this, all right, so say we have something like looks like this, where they give you y1 again, all right, and they give you a differential and we want to find a general solution. So what you want to do is find that y2 first using that formula. So what I want to do is make sure that this is in standard form. So in order to do that, this is just a minus sign. Okay, in order to do that, I'm going to divide everything by x squared, and then it gives me y double prime minus 3 over x y prime plus 4 over x well, one thing here, I didn't want this, sorry, I didn't want that x there. It should have just been 4. So let's get rid of this x here. Okay. All right, so here you could see like p of x is going to equal that negative 3 over x. All right, and now we can use that formula that we have, which is going to be y2 is equal to, so you start with y1, which in our case was what we start with, x squared, integral e raised to the negative p of x divided by y1 squared. So y1 was x squared, and we are squaring that and then doing our integral this way. Okay, so we wind up getting the integral of 3 over x is just going to be 3 ln, so you get negative 3 ln x over x to the 4th dx. So let's simplify that inside. So I get x squared integral, this is going to wind up being e to the ln x to the negative 3rd, which is just x to the negative 3rd. Oh, I messed up my sign. So be careful here, right? In the formula, and this is good that I did this. In the formula, right, if you go all the way up, it has a negative. And if you notice, I forgot to cancel out that negative there, right? So this actually should have been negative, negative, right? And then that gets rid of our negative here, our negative here, our negative here. So we just get x cubed. All right, sorry about that. X cubed over x to the 4th dx, but that's easy because that's just 1 over x dx. So we get our y2 to now equal x squared ln of x. Don't worry about the plus c, because now we can write our general formula, which our general solution is going to be y equals c1 y1, which was x squared, plus c2, and then y2, which is x squared ln x. Okay, so again, just to recap a little bit, right? You're using this formula to find y2, right? So that's what we did here, right? This whole thing here was to find what y2 is equal, and then you could write it into that general solution, just like from 4.1. When you have both solutions, you just put a constant in front and label it C1 and C2. So that's 4.2.